So one of the most important things that they're going to ask you to do on the AP exam is to interpret your answer. And like we've talked about before, when it comes to math, we're very rarely looking for something to be in your own words. There are specific words, there is specific language that we are looking for. And so that's what we're going to look at today. What are the specific components of an interpretation answer that you will be expected to provide? Okay. You want to be brief and you want to get straight to the point. You don't want it to be a long-winded answer. You don't need to add in a bunch of flowery language to try and make yourself sound smart. You just want to get straight to the point. Like I've told you before, our AP trainer always said, SEAL Team 6, get in, get out, and move on to the next thing. So make it quick, make it brief, and make it specific. Okay, so we're going to talk about derivatives and integrals. We've talked about both these before, but we're going to get real specific into exactly what you need to have. So remember that the difference between derivatives and integrals, derivative values are instantaneous values. So we're talking about what's happening at a specific moment in time, a precise instant. So you always want to interpret your derivative at a specific time. You need to use that word at whenever you're talking about the value obtained from a derivative. So there's three components that you need for the interpretation of a derivative. You need to have units, both for your answer and both for the time. So you want to say the answer is blah, 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 whatever the units are at time, blah, 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 whatever the units are there. So your X and your Y need to have units. You want to be sure that you include a rate as part of your answer because that's typically what a derivative represents. And then you need to include context for the problem. So don't just have like a generic response plan to go. You need to tie it into the information that you've got. Okay. With integrals, they are different. There's three components as well, and they're very similar. But the difference between a derivative and an integral, like we said, a derivative happens at a specific moment. However, an integral represents a value that happens over an interval. So you want to use a phrase that contains over the interval, over the time period, whatever. You don't want to use the word at for any reason when you're interpreting an integral. Okay, so the three components with an integral that you need are, again, units. Now, on that 4-1 to 4-3 quiz that we took, which I know you haven't seen yet, but we'll hand back the next time I see you. On that 4-1 to 4-3 quiz, the reason a lot of you lost points, and for a lot of you it was the only reason you didn't get 100%, you included units for your answer, but you did not include the units for the time. Everything needs a unit. So you need to include units for both the time interval and the value that you calculated. And be sure that you use phrases like total or net as part of your answer, depending on the situation. And then you want to always, same thing, include a context for the problem. Tie it back to what we know. They're not looking for a generic answer that you can use every time. It needs to be relevant to the problem that you are talking about. Okay? Now, I know we've said this before. This is kind of a silly acronym, but the acronym NUT can be helpful to remember all of the parts for both of them. N for noun. What did you find? U for units. And then don't forget, your time needs units as well. And then T is for time. If it's a derivative, you want to say at time, whatever. If it is an integral, then you want to say on the interval. Don't use the word between. Don't say between here and here. It's ambiguous. Do you include the endpoints? Do you not? So we don't want to use that word between. You don't want to say like after 12 hours. You literally want to use the words on the interval. Okay, so I'm going to show you two examples here, and then I want to tell you one extra thing about integrals. So here is the first example. It says a local store opens at 9 a.m. and the amount of people in the store can be modeled by A of t over the interval 0 less than or equal to t less than or equal to 7, where t is measured in hours and 9 a.m. corresponds to time t equals 0. Find a prime of 3 and using correct units, interpret the meaning of the value in the context of the problem. So a prime of 3 represents a derivative. This tells me that I need to find a specific value. I need to use the word at, and I need to make sure that I call it a rate. Okay, now this function is disgusting. I would say let's go ahead and try that yourself to make sure that you're using the calculator correctly. And my recording just got interrupted, so I don't know if part of that got cut off or not, but I'm going to get my calculator and come up with that answer. Okay, in my calculator, I get the value a prime of 3 to be negative 1.281. Remember, the standard is always correct to 3 decimal places past the decimal. Okay, so that is the answer. Now, a derivative always represents a rate, and so since this rate is negative, that means that we are decreasing. Now, you want to be really careful when you get a negative that you never use a double negative when you're describing. So you don't ever want to say decreasing at a rate of negative blah, blah, blah. If you use the word decreasing, then you need to give a positive number because decreasing implies the negative. I think it's safest to just use the word changing, and then that way you've always got your signs correct. You can leave it exactly how it is. So if a of t represents the number of people in the store, then a prime of t represents the rate of change of people in the store. And so at time t equals 3, if 9 a.m. is t equals 0, then t equals 3 would be 12 p.m., noon. So here's the sentence that I would write to interpret this derivative. So here's what I would say. The number of people in the store is changing at a rate of negative 1.281 people per hour at time t equals 3 hours after 9 a.m. So again, if we look at those 3 pieces, N is the noun. What did you find? You found the rate of the number of people. That's the important part of the context of the problem. That's what that function is measuring, is the number of people in a store. Okay. The word at, very important. This is a derivative. You must have the word at in your answer. We've indicated that this is a rate, and we used correct units to describe the rate, people per hour. And then that is happening at time t equals 3, and we have the units for time as well. You don't want to just say t equals 3 and leave that number dangling with no unit, okay? So once again, what did you find? What are the units for everything, and what is the context of the problem? Derivatives always represent a rate. Let's look at an integral. Okay, number 2 says, Jill is jogging along a straight path. For 0 less than or equal to t less than or equal to 25, Jill's velocity is given by the differentiable function v of t, where v of t is measured in meters per minute and t is measured in minutes. We want to find the integral from 0 to 25 of the absolute value of v of t dt using correct units. That's a typo. Interpret the meaning of this value in the context of the problem. Now, the first thing that I want to mention here is that there is a difference between finding these two different things. All right. The first integral does not have an absolute value, and the second one does. Now, one thing that I noticed on the quiz is that most of you are interpreting your answers as the absolute value definition, which is not entirely correct. So the first one represents the net change in position. Okay, so remember, when we're doing an integral, part of that curve could be below the x-axis. So you have some positive area, some negative area. That means you could be going forwards for part of it, backwards for part of it. So the absolute value of velocity gives you the net change in position. However, if I look at the absolute value, that takes away the fact that I might be going forwards or backwards, and that ends up finding the total distance. Okay, that's very different. So for example, let's say that I am walking and I go 2 steps forwards and then 3 steps backwards, and then I go 5 steps forwards and then I go 1 step backwards. Well, where did I end up? I ended up at 4. That would be the net change in my position, is 4 units, whatever that would be. The total distance would be the total number of steps that I took regardless of the direction I went. So the total distance in this case would be 2 plus 3 plus 5 plus 1, which is 11. So those are 2 very different things. That would be an important thing to put on a flashcard. So there's 2 things that we need to figure out. We need to use our calculators to evaluate that integral. Now, you do have an absolute value button on your calculator, and you do need to include it because it will give you a different answer. If you go to your math menu and you arrow over to number, then number 1 is absolute value. So go ahead and put that in your calculator, and let's find the value of this integral. Now, there's 2 things that I want you to remember about this. And that is that 1, you need to make sure that you are in Radian mode. I know a lot of you taking physics probably have your calculator in degree modes for some parts of the day. Make sure you switch it back. And then 2, remember math 9 is how you're going to get to your integral. Now this function is kind of gross, so my calculator is taking quite a long time to think this one through. So yours might be doing the same. We'll just hold on a second while it's thinking. All right, I think that took about 30 seconds for mine to click through. But so here is the answer that I get. I get the integral from 0 to 25 of the absolute value of v of t dt is approximately, once again, we're always looking for 3 decimals, 1,128.34. Nope, sorry, that answer was wrong. I realized right as I finished writing that, that I had typed something wrong in my calculator. So the correct answer, 0 to 25, absolute value of v of t dt is approximately 3,381.996, which at first I thought was really long, but that's roughly a 5K, so that's not terrible. No, it's not even a 5K, it's a 3.3K roughly. Okay, so again, we want to interpret this. This is an integral, so that means we're going over a time interval. It's an absolute value, which means it's a total distance traveled. Our distance is in meters. Remember, the integral of a rate is an amount, so it's no longer a rate. Velocity was a rate. When we integrate now, we're talking position function. And then our time is also measured in minutes. So here's the sentence that I would write. So here are all the components again. We are talking about Jill and how far she's traveled. That's your noun, and that's the context of your problem. Because this was absolute value, we are talking about total distance versus net change in distance or whatever. We have got the answer rounded to 3 decimal places, and we have units for that answer. And then we use those 3 magic words on the interval. 0 less than or equal to t less than or equal to 25 minutes. You must have units on your time. And again, I am always going to be looking for these 3 specific words. I don't want to see after 25 minutes. I don't want to see between 0 and 25 minutes. None of those words are mathematically precise on the interval. Just remember, interval sounds like integral. So you've got to have that word whenever you're interpreting an integral, okay? So what you've got then for today is some practice looking at some provided answers and deciding how to make them better and coming up with some of your own as well. And I will see you later.